sine of 1 over beta n minus alpha n sine of 1 over alpha n. So this is complicated, kind of, right? Kind of complicated. So I want to simplify it. How I will make this guy equal 0 if we take, for example, alpha n equals 1 over 2m pi. Right. So then 1 over alpha n is just 2m pi. Sine of 2m pi is just 0, right? So everywhere it equals 0. So that this equals just a beta n squared over beta n minus alpha n times sine 1 over beta n. So I want to keep dn away from 0, from this value, right? I don't want the dn to get closer to 0. I want to keep it away, right? So very nice, and also I will more or less want beta n squared is more or less equal to beta n minus alpha n, right? Right. So that the limit will just, for example, I think this equals 1 or half, then this very close to 1, then the product is at least 1/2, right? So that will keep dn from approaching 0. That will give our counterexample, yes? Right. So now I'm going to take beta n equals, or 1 over beta n equals the 2m pi plus pi over 2. So then this value would just be 1, right? So that will give me beta n squared over beta n minus alpha. Right, have this one. So now the only thing I need to check is this one. That's a beta n squared is approximately beta n minus alpha n, right? That's the only thing I need to check. Right. So now let me just plug in the formula for alpha n and the formula for beta n. So this will give me 1 over 2m pi plus pi over 2, and then I'm sorry, I need to put which is larger, which is smaller, because the beta is larger now, right? So let me just put 5 pi. I'm sorry, change it to 5, right? Let's add 1 more 2 pi, right, to that, right? So then this is just, so I will, because in the problem beta n is larger, right? So I put 5 here. So this, oh, I'm sorry, not make it larger, make it smaller, right? Because the reciprocal. I'm sorry. I think the minus is 3 pi over 2, right? Smaller, right? So that the beta n is larger than alpha. I'm sorry. So, but essentially there's no difference. And now beta n is 1 over 2m pi minus 3 pi over 2 minus 1 over 2m pi. So the numerator I keep. Then the denominator, in the denominator is still a quotient, right? So this is just a 2m pi minus 3 pi over 2 times 2m pi. And then it should be 2m pi minus this 2m pi minus 3 pi over 2, that's a 3 pi over 2, right? Right. So, and that equals, I'm sorry, I forgot square, right? Beta n squared, right? Beta n squared, right? Beta n squared. So this number I flip over, this is 2 over 3 pi. And then this denominator I flip over, that's a 2m pi minus 3 over 2 pi times 2m pi, and divided by 2m pi minus 3 over 2 pi squared. Okay. So I can cancel one factor. This is 2 over 3 pi, and this is a 2m pi over 2m pi minus 3 over 2 pi. Right? Cancel one pi. Right? And then if I send n to infinity, what is the limit of this quotient? Yeah, it's just 2 over 3 pi, right? Because this 2n pi cancel with this 2n pi more or less, right? This is a finite number. Right? So this is just 2 over 3 pi.